Welcome back, everybody. Today, we're going deep into this fascinating area of AI. Speech Understanding Language Models,
Yeah.
SELMs. You've probably heard a lot about LLMs.
Oh, yeah.
Those impressive language models that can write poems and even code. Well, think of SLMs as their, sophisticated cousins,
Yeah,
specifically designed to understand the nuances of human speech.
exactly. And while we've seen this explosion in LLMs with all sorts of open source projects popping up, the development of cutting edge SLMs has really been dominated by big tech companies with massive resources. It's been kind of like a guarded secret, with most academic researchers lacking the data and the computational power needed to really compete.
Yeah, it's like having this recipe but missing a key ingredient.
Mm-hmm.
But thankfully, there's a project that's changing the game.
Yeah.
OSM, the Open Speech Understanding Model.
Yeah.
It's like a beacon of open science in a field that's often been shrouded in secrecy.
Absolutely. OSUM is all about building a powerful SIMM, but using limited resources and making it accessible to a wider research community. It was developed by the ASLP at NPU Group at Northwestern Polytechnical University in China, and it's already making waves.
I'm so curious what makes OSUM so special. What can it actually do?
Well, get this. OSUM can handle not just one, but 8 different speech tasks. Of course, there's speech recognition, but it goes way beyond that. We're talking about detecting vocal events like laughter or sighs, recognizing emotions in someone's voice, and even identifying their speaking style.
8 different tasks. That's incredible.
Yeah.
But how can it achieve all of this with limited resources?
Right. It sounds almost too good to be true.
Yeah.
That's where the clever engineering comes in. The team behind OSUM combined a fine-tuned Whisper encoder, which is known for its efficiency, with a Qwen2 LLM. Whisper's strength is in quickly and accurately processing speech, while Qwen2 brings this powerful language understanding to the table. And this combination lets OSUM deeply analyze speech without needing a supercomputer to run it.
It's all about striking that balance.
Yeah.
Between power and efficiency,
Mm-hmm.
making it accessible to researchers who might not have those Google-scale resources.
Mm-hmm.
Okay. I'm impressed. But I think we need to step back for a second.
Great.
Think about the bigger picture here. Why should someone who isn't a speech AI expert care about open source SULMs, like OS? What's the so what here?
Right. That's a great question. It really boils down to democratizing research and innovation. By making this technology more accessible, OS opens up all these possibilities for developers, researchers, and even everyday users. Imagine a world where any developer can build apps that truly understand how we speak and how we feel.
Okay. That sounds like a future I want to be a part of.
Yeah.
But let's dive into the specifics of OSUM. How well does it actually perform on these 8 tasks? Can it really compete with these industry giants with their massive data sets and their computational firepower?
You might be surprised to hear this, but OSUM achieves comparable and sometimes even better performance than these industry models on many tasks. And here's the kicker. It does so using significantly less training data. We're talking 44,100 hours of data for OSUM
Wow.
versus hundreds of thousands, even millions for some of these industry behemoths.
Hold on. That's a massive difference.
Yeah.
How are they pulling off such impressive results with like a fraction of the data?
Right. It seems like they must have some secret sauce.
Yeah.
Well, one of their key innovations is a training strategy they call ASR plus X. Essentially, they train the model to perform automatic speech recognition, or ASR, alongside another target task, like emotion recognition.
So it's like learning 2 things at once.
Uh-huh.
Does that actually make the model more efficient?
Exactly. It's kind of like learning to ride a bike while juggling. Your brain is forced to coordinate multiple tasks simultaneously, and that actually makes you better at both in the long run. And in OSUM's case, this approach not only boosts efficiency, but it also allows the model to learn more generalized representations of speech. So it's not just learning to transcribe words, it's understanding the underlying patterns and the nuances that connect speech to emotions, speaking styles, and other complex aspects of how we communicate.
That's fascinating. So by training on multiple tasks at the same time, OSUM develops this deeper understanding of the relationship between the words we say and how we say them. It's almost like it's learning to read between the lines of human conversation.
Precisely. And this ASR plus X strategy also lets OSUM leverage both the text transcript of the speech and the acoustic features, like the tone and the pitch. This dual modal approach is particularly beneficial for tasks like speaking style recognition, where understanding those subtle variations in delivery is crucial.
Speaking style recognition.
Yes.
Now that sounds intriguing. Tell me more about that.
It's a fascinating area of research, and one that's not often included in mainstream SULMs. It's all about identifying how someone is speaking. Are they being formal or casual? Are they telling a story or giving a lecture? Things like that. Imagine a model that can tell the difference between a news report and a bedtime story just by analyzing how the speaker's delivering it.
Right.
That's what OSUM is capable of.
That's incredible. So how does OSUM perform on this unique task? Can it really tell the difference between, say, a newsreader and a poet?
Oh, absolutely. And what's really impressive is that it significantly outperforms text-only models on this task, which highlights the power of that dual modal approach we were talking about. It proves that understanding those nuances of speech goes beyond simply recognizing the words being spoken.
That's remarkable. But let's be real.
Yeah.
No model is perfect. What are some of the areas where OSUM still needs work?
Right. No model is perfect. And OSUM is no exception. While it's remarkably good at recognizing most emotions, it struggles a bit with disgust and fear.
Yeah. I mean, those are pretty subtle emotions to pick up on,
Yeah.
even for humans sometimes.
Yeah.
So I can see why that would be a challenge for an AI.
Exactly. And the researchers believe that this difficulty stems partly from a lack of training data, specifically for those emotions.
Oh, so it's more of a data problem, not necessarily a flaw in the model's design.
Precisely. They're hoping to address this in the future by using OSM itself to label more data for those underrepresented emotions.
Oh, that's a really neat idea.
Yeah.
So it's like OSM is helping to create its own training materials to become even more well-rounded.
Yeah.
Are there any other areas where the researchers see room for improvement?
Yes, there are a couple of others. For instance, OSM still lags behind in speech-to-text chat, essentially that back and forth natural conversation.
Okay.
It's not quite ready to replace our favorite chatbots just yet.
So it's great at understanding various aspects of speech, but not quite ready to hold a deep philosophical debate.
Not quite. The researchers believe this limitation is likely due to a lack of English conversational training data, although it performs much better in Chinese.
Okay.
But again, this is something they're actively working on.
It sounds like the team behind OSUM isn't resting on their laurels. Let's switch gears a bit and talk about the open science aspect of this project.
Yeah.
How does OSUM deliver on that promise of transparency and accessibility?
This is where it gets really exciting. The OSUM team is incredibly transparent with their work. They've made their entire data processing pipeline and training details public, which is pretty rare in the world of cutting-edge AI.
Yeah. Wow. That's a big deal, especially when you consider how much effort goes into protecting intellectual property in this field. Why do you think they chose to make OSUM open source?
I think it speaks to their commitment to advancing the field as a whole. By making their methods and their data public, they're not just building a better speech AI, they're fostering collaboration and innovation within the research community. They're essentially giving other researchers the tools and the knowledge to build upon their work, which could lead to all sorts of exciting new discoveries.
It's like they're throwing open the doors and inviting everyone to join them on this journey of exploration. This open source approach could have a huge impact on the field, don't you think?
Absolutely. It's already generating a lot of buzz. Researchers now have this opportunity to dissect a state-of-the-art SUL, understand its inner workings, and potentially build upon its strength.
It's like they've given us a blueprint
Yeah.
for building the future of speech AI. And it's all thanks to their commitment to open science. We've covered a lot of ground here, from the technical details of OSUM's architecture to its impressive performance on various speech tasks. But I want to dive even deeper. What specific results have caught your eye? Where does OSUM really shine?
Well, as we mentioned earlier, it excels in Chinese ASR tasks, consistently outperforming other models on several benchmark data sets. This is particularly impressive given the relatively small amount of training data it used compared to these industry giants.
Yeah, it's like a David amongst Goliaths.
Yeah.
So OSUM is a champion in its weight class, so to speak.
Exactly. And that efficiency extends to other tasks as well. For instance, in speech recognition with timestamps, OSM comes remarkably close to the accuracy of a dedicated GMM HMM model, which is the gold standard for that kind of precise timing information.
Wait, so it can pinpoint exactly when each word is spoken?
Yeah.
Almost as well as a specialized system designed just for that purpose?
Yes.
That's amazing.
Right?
What about the more nuanced tasks, like vocal event detection? Can it accurately pick out laughs and sighs from a continuous stream of speech?
It does a pretty good job. Even with the challenge of having speech and vocal events mixed together in the training data, it manages to identify most events accurately.
I'm sensing a butt coming.
Well, there is a slight caveat. On a public test set that contained only isolated vocal events, OSUM's performance dipped a little bit.
So it seems like having the context of the surrounding speech actually helps it perform better. It's like it's using the flow of the conversation to make more informed decisions.
Precisely. It relies on those acoustic cues we talked about to really excel. Interestingly, on their internal test set, which did include that mix of speech and events, OSUM actually outperformed other models, including one that specifically treats speech as a separate event.
So it's more robust and adaptable to real-world scenarios where things aren't always neatly separated into these isolated events. It's learning to understand speech the way humans do,
Yeah.
as this continuous flow of information. That's pretty remarkable.
Exactly. And now moving on to emotion recognition. This is where things get even more interesting. OSUM shows real strength here, particularly on a challenging data set focused on subtle emotions where it surpassed several other top models.
Okay. Now, you've definitely piqued my curiosity.
Oh.
But you mentioned earlier that it has trouble with some emotions. What's the story there?
Yes, disgust and fear still pose a challenge. And that's likely due to that limited training data we talked about earlier. But what's really exciting is that the researchers are planning to use OSNet itself to label more emotional data. This could create a more balanced and robust data set for future training and help the model overcome this limitation.
So it's like OSIM is on this continuous journey of self-improvement.
Yeah.
All right, let's talk about speaking styles. How well can OSIM distinguish between a newsreader and a poet, for example?
This is where that dual modal approach really pays off. OSM significantly outperforms text-only models in this task. And think about it. A poem and a news report might use similar words, but the way they're delivered is completely different.
Right.
OSM can pick up on those subtle vocal variations, those tiny shifts in tone and cadence that really convey the speaker's intent and style.
It's like it's listening to the subtext, the unspoken messages embedded in the way we speak. That's incredible. What are some of the specific speaking styles it can recognize?
It can distinguish between a surprising variety of styles, including news and science reporting, horror stories, fairy tales, customer service interactions, poetry readings, audiobooks, spontaneous conversations, and more.
Wow, that's quite a range. It seems like OSM's capable of recognizing this wide spectrum of human expression. Are there any styles that it struggles with?
There's definitely room for improvement in some areas. For example, it still has some difficulty categorizing poetry and prose, horror stories, and other less defined styles. But as with the emotion recognition challenge, they're planning to use OSUM to label more data and refine its performance.
It seems like this data labeling strategy is like a recurring theme.
Yeah.
And for good reason. It's a really powerful way to leverage OSUM's existing capabilities to address its limitations and continuously improve its performance.
Okay. What are the more basic tasks like figuring out a speaker's gender? How does OSUM fare in that area?
OS does exceptionally well in gender classification, achieving near-perfect accuracy on one data set.
Near perfect. That's incredible. It sounds like it's a natural at this task. It is. However, there is this slight suspicion of overfitting on that particular data set. So it might have memorized the specific voices rather than learning the underlying patterns that distinguish male and female voices.
So it aced the test, but maybe not in the way that we'd ideally want. It's like a student who crammed for an exam and got a perfect score, but might not have truly grasped the material.
Exactly. But it's important to note that it still outperforms other models on different data sets. So its overall gender classification ability is strong. It just highlights the need for careful evaluation and the potential pitfalls of relying too heavily on any single data set.
Right. It's a good reminder that even the most impressive AI models need to be rigorously tested and evaluated to make sure that they're truly learning generalizable patterns and not just memorizing specific examples. And what about age? Can OSM tell the difference between a child and an adult based on their voice?
That's a tricky one, as you can imagine. Voices change so much as we age. And there can be a lot of overlap between different age groups. The researchers actually simplified the age categories to child, adult, and old because they found it was too difficult for the model to reliably distinguish between teenagers and adults.
That makes sense. I can see how that would be a tough call, even for humans sometimes.
Exactly. And interestingly, OSUM outperforms another model, Qwen2 Audio, in this task, possibly because Qwen2 Audio uses this much more granular age categorization. It seems that simplifying the problem can actually lead to better results in some cases.
So sometimes less is more, even in the world of AI. Fascinating. Okay, before we move on, I have to ask, are there any funny quirks or unexpected things that the researchers discovered about OSM?
Well, one thing that stood out was its performance on the speech-to-text chat task. It actually lags behind Qwen2 Audio in this area, particularly when it comes to English conversation.
So it's not quite ready to be our witty conversational AI companion.
Not yet. But what's interesting is that it performed much better on a Chinese conversational test set. The researchers think this discrepancy might be because they trained it to perform speech recognition first before attempting the chat portion. So it seems like it needs that solid foundation of understanding the spoken words before it can really try to be clever and conversational.
It's like learning to walk before you can run. You need to master the basics before you can really tackle the more complex stuff.
Exactly. And they're actively working on improving its chat capabilities. So maybe in the future we'll be having those deep philosophical discussions with OSUM after all.
Okay, so we've covered a lot of ground here. We've explored OSUM's capabilities, its strengths, and its limitations. But I think it's important to step back and ask the big question. What's the so what of all these results? Why should our listeners care about OSUM? What makes it so special?
Well, it all boils down to this. OSUM proves that you don't need a billion-dollar budget and a data center the size of a small city to make significant advancements in speech AI. It challenges this assumption that cutting-edge research requires massive resources, and it makes it clear that innovation can flourish even in resource-constrained settings.
So it's a win for accessibility, for democratizing research and innovation in this field. It's like a beacon of hope for those smaller research groups and independent developers who might have previously felt excluded from this exciting area of AI.
Absolutely. OSUM is this powerful example of what can be achieved with smart engineering, creative problem solving, and this commitment to open science. It's an inspiration to anyone who believes that great ideas can come from anywhere, regardless of their budget or resources. And that's something worth celebrating.
Yeah, it really is a testament to their ingenuity and their determination. They've managed to push the boundaries of what's possible with limited resources.
Yeah. And speaking of pushing boundaries, let's talk about some of OSUM's future ambitions. What are the researchers hoping to tackle next? Well, the team has some ambitious goals. They're looking to expand OSUM's functionalities even further. One area they're particularly excited about is adding language and accent identification.
Oh, wow. That would make it even more versatile and applicable to real-world scenarios. Imagine a world where any app could understand not just what you're saying, but how you're saying it, regardless of your language or accent.
Exactly. It could revolutionize the way we interact with technology. Imagine personalized learning tools that adapt to your accent or communication platforms that translate between languages while preserving the speaker's unique vocal characteristics.
Okay, the possibilities are mind-boggling. It's like we're
Yeah.
taking another step towards breaking down those barriers of language and culture. Are there any other exciting features in the pipeline?
Oh, yes. They're also aiming to make OSUM truly multitask capable.
Okay,
Right now, it can only handle one task at a time,
right.
but they're working towards a future where it can identify multiple things simultaneously. Emotion, age, gender, speaking style, you name it.
So it'd be like having this super-powered speech analysis engine.
Yeah.
It can analyze the speaker's voice and tell you all sorts of things about them, how they're feeling, their approximate age, their gender, their speaking style, all at the same time.
Yeah.
What would that mean for practical applications?
Well, the implications are huge. Think about all the time and effort that goes into manually labeling audio data for research or other purposes.
Yeah.
OSUM could potentially automate a lot of that, making research and development much faster and more efficient. It would be a game changer for fields like linguistics, psychology, and even marketing.
It's like giving researchers and developers a superpower. They'd be able to analyze vast amounts of audio data with incredible speed and accuracy. It could lead to all sorts of innovative applications. Are there any other ambitious goals on their list?
Yes, they're also exploring the possibility of incorporating full duplex voice interaction.
Full duplex. That sounds intriguing. What exactly does that mean?
It essentially means being able to talk and listen at the same time, just like we do naturally in conversations. Most current speech AI systems are kind of like walkie-talkies.
Right.
You have to wait for one side to finish speaking before the other can respond.
So they're kind of stuck in that back and forth mode,
Yeah.
which can feel a bit clunky and unnatural.
Exactly. But with full duplex capabilities, OSUM could engage in more fluid and natural-sounding conversations. It could even handle interruptions or overlapping speech, just like we do in real life.
That would be a game changer for things like virtual assistants and chatbots. They'd feel much more like real companions. You could have actual conversations with them, bouncing ideas back and forth.
Precisely. And the team is even thinking about how they could use this full duplex capability to make OSM more expressive. Imagine it being able to match your emotional tone during a conversation, or even mimic different speaking styles. You could have a conversation with OSM that feels as natural and engaging as talking to another person.
Okay, now that's getting into some seriously sci-fi territory. It sounds both amazing and a little bit unnerving. It makes you think about what it truly means to communicate and connect with another being, whether human or artificial.
It's definitely a thought-provoking concept, and it really highlights the importance of considering those ethical implications of AI as it becomes more sophisticated and integrated into our lives.
You're right, it's a conversation we need to be having.
Mhm.
But for now, let's bring it back to OSUM and its incredible potential. What are some of the other specific goals the researchers are pursuing?
Well, one area they're actively exploring is improving OSUM's performance in low-resource scenarios. They want to make it even more efficient, more capable of learning from limited data. This would be huge for researchers who are working with less common languages or dialects.
That's an important goal, especially if we want to make sure that speech AI benefits everyone, not just those who speak the most widely spoken languages.
Absolutely. They're also working on refining OSUM's ability to understand and respond to different emotional cues. They want to make it more sensitive to those subtle nuances of human emotion, allowing it to provide more empathetic and personalized interactions.
Imagine a virtual assistant that can not only understand what you're saying, but also sense how you're feeling and respond accordingly.
Yeah.
It could offer words of encouragement when you're down or celebrate your successes with genuine enthusiasm.
It's about moving beyond simply processing language to truly understanding the human experience, and that's a really exciting prospect.
It really is. It's like we're on the cusp of this new era of human-computer interaction, one where technology understands us on a deeper level and can truly enhance our lives. But I think it's important to remember that none of this would be possible without the team's commitment to open science.
You're absolutely right. That commitment is the foundation upon which all of this progress is built. And they plan to continue sharing their research, their data, their code, everything, to ensure that the technology remains accessible to the wider research community.
It's that spirit of collaboration and transparency that truly sets OSUM apart. It's not just about building a better speech AI. It's about building a better future for everyone.
It's about democratizing access to knowledge and empowering others to contribute to this exciting field.
It's about breaking down barriers and fostering a spirit of shared discovery.
It's about reminding ourselves that even in a world that's increasingly dominated by big tech, innovative ideas can still come from anywhere.
I couldn't have said it better myself. We've talked a lot about OSUM's future goals and ambitions, but I'm curious to hear your perspective. What are you personally most excited about? What do you think the long-term impact of OSUM could be?
Well, what excites me most is the potential of OSUM to unlock all these new possibilities in fields beyond just computer science. Imagine the impact it could have on healthcare, for example.
Oh, absolutely. I can see it being used to develop personalized mental health tools that can detect those early signs of depression or anxiety just by analyzing a patient's voice, or to create assistive technologies for people with speech impairments, allowing them to communicate more effectively.
Exactly. And think about the potential in education. OSUM could be used to develop personalized learning platforms that adapt to each student's unique learning style and pace, providing tailored feedback and support. It could revolutionize the way we learn, making education more engaging and accessible.
It's incredible to think about all the potential ripple effects that OSUM could have. It's not just a technological breakthrough, it's like a catalyst for positive change.
It really is. And that's why I'm so optimistic about the future of speech AI, especially with projects like OSUM leading the way. It's a testament to the power of human ingenuity and the transformative potential of open science.
It's truly inspiring to see a project like OSUM really pushing the boundaries and making this field more inclusive. We've talked about its impressive capabilities and its ambitious goals, but now I'm curious what's next for OSUM. In the more immediate future, I mean. What concrete steps are the researchers taking to actually achieve these goals?
Well, they're not wasting any time, that's for sure. One of their top priorities is expanding the data sets that they use to train OSUM. They really recognize the importance of diverse and representative data, especially when it comes to tasks like emotion recognition and speaking style identification.
That makes sense. The more diverse the data, the better OSUM will be at understanding that full spectrum of human expression. But how do they actually plan to go about expanding these data sets?
Well, they're taking this multi-pronged approach. They're actively collaborating with other research institutions and organizations to gain access to new data sources. And remember that clever data labeling strategy we talked about?
Right.
Where they use OSUM itself to label new data?
Right.
Well, they're going to be ramping that up as well.
So it's like they're bootstrapping their way to better data,
Yeah.
using OSM's existing capabilities to create the resources it needs to grow even stronger.
Exactly. And they're also exploring new ways to make OSUM more robust and adaptable.
Okay.
One avenue they're pursuing is incorporating techniques from the field of transfer learning.
Transfer learning. Refresh my memory. What does that involve?
It's this fascinating area of machine learning, where a model trained on one task can be adapted to perform a different but related task. So imagine training OSM on a massive data set of English speech,
Okay.
and then fine-tuning it on a smaller data set of, say, French speech. It could learn to understand French much faster and more efficiently.
So it's like building upon this foundation of existing knowledge rather than having to reinvent the wheel every time. That's really clever. How could transfer learning benefit OSM in the long run?
Well, it could make OSM much more adaptable to different languages and accents. It could also make it easier to customize OSM for specific applications. So imagine fine-tuning it on a data set of medical conversations
Right.
to make it more accurate at transcribing and understanding medical jargon, or adapting it to the fast-paced world of financial markets to make it a whiz at analyzing earnings calls and market trends.
It's like giving OSM a set of specialized skills, allowing it to excel in all sorts of different fields and applications. Okay, but with all these ambitious goals and ongoing developments, what are the researchers most excited about? What do they see as the ultimate potential of OSM?
I think their ultimate vision is to create this truly human-centric speech AI.
Okay.
One that not only understands the words we say, but also the emotions we convey, the intentions behind our words, and all those subtle nuances that make each of us unique.
It's a beautiful vision, isn't it? A world where technology understands us on a deeper level, where it can enhance our communication, deepen our connections, and empower us to achieve more than we ever thought possible.
It's a world where speech AI is not just a tool, but a true partner in human endeavor. And I, for one, am incredibly excited to see where this journey takes us.
Me too. It's been a fantastic deep dive into the world of OSUM and open science in speech AI. We learned about its capabilities, its ambitious goals, and the dedicated team behind it all. But as always, we want to leave you with something to ponder. Now that powerful speech understanding models like OSUM are becoming more accessible, what applications can you imagine for this technology? How could it change the way we live, work, learn, and connect with each other? Let your imagination run wild and share your thoughts in the comments below. Until next time, keep exploring, keep learning, and keep diving deep into the world of fascinating ideas.
Happy exploring!